my video froze, so I'm going to show this one more time. This was 182, and we were just finishing up putting our answer that both are correct. So they both have fractions that are equivalent to 1. So let's move on to 183, still working on green pages. So this will be part 2 of my video, but we're still working on the same material. Write 2 fractions that are equivalent to 5. Now 5 is a whole number, okay? So there are 2 things that I want you to know about making whole numbers. First step, put 1 under your whole number. That's your first step. So we want a 5. So step 1, put a 1 under it. That is a fraction. That fraction equals 5. That means I want 5 pizzas. I don't want to cut them into parts yet. Now, the next thing is, our rule says whatever I do to the top, I have to do to the bottom. So step 2, multiply or divide. And remember, whatever you decide to do, you have to do the top and the bottom. So I don't want to divide here because 1, I cannot go any smaller than 1. So I'm going to multiply. So to make an equivalent fraction, because they want 2 of them, to make an equivalent fraction, I'm now going to multiply. And you know me, I'm going to pick times 2, just because I know my 2's really well. So my equivalent fraction is going to be 5 times 2 is 10, and 1 times 2 is 2. So I could take 5 pizzas and cut them into 2 parts, cut all 5 pizzas into 2 parts, and then I would end up with 10 parts. So I'm going to draw that so you can see it. So here's my 5 pizzas. That's what I first started with. That's my first fraction, 5. And each pizza has 1 part because we're not cutting it. Now I want to cut it times 2. So I'm going to cut every one of them into 2 parts. Now let's count those parts. We have 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves, 9 halves, and 10 halves. So that's how I get 10 out of 2. Did I change the pizza? Only by adding a line, didn't I? Still 5 pizzas, but this time there are 10 out of 2 because 1 pizza has 2 parts. These are my equivalent fractions. So my answer, 5, oops, let me change back to black so y'all can see. 5 over 1 is equal to 10 over 2. I could have done times 3. We could have done times 4. We could have done times 5. We could have done times 6. You can pick whatever you want as your multiplication factor to make that equivalent fraction. Whatever I do to the top, I do to the bottom, and I know they're equal. We can also butterfly these. 1 times 10 is 10. 2 times 5 is 10. So I know they are definitely equivalent fractions. All right. Kaya ate 3/6 of a banana. Zoe ate an equivalent amount. Which fraction shows how much of a banana Zoe ate? Circle the letter of the correct answers. Okay, so we need to find out what is equivalent to 3/6. So what I want you to do is to write 3/6 beside every one of your fractions. Okay? Then we're going to butterfly. If the wings match, we know they're equivalent. So let's start with A. 3 times 3 is 9. 6 times 1 is 6. Does 6 and 9 match? No. So A is not equivalent. Let's try B. Bottoms up. 3 times 3 again. We already know is 9. Other side, 6 times 2. 6 times 2 is 12. Is 12 and 9 equivalent? No. B is out. Let's try C. 8 times 3 is 24. 6 times 5 is 30. 30 and 24, are those equivalent? No. C is out. Now let's butterfly D. Bottoms up. 2 times 3 is 6. Bottoms up. 6 times 1 is 6. Is 6 and 6 equivalent? Yes. So our equivalent fraction is D. Now Landon chose A. How did he get that answer? So let me rewrite A. A was 1/3 and 3/6. What did he do wrong? Well, we know it's not equivalent. So maybe he did times 2 and times 3. And we know we can't do two different things. Maybe he thought this was a half. But somehow he messed up. So I'm going to say that he did not multiply them by the same number. I'm going to say he multiplied the denominator by 2 and the numerator by 3. And we know you can't do that. You have to use the same factor. You have whatever you do to the bottom, you have to do to the top. So that's the only thing I can figure out he did wrong is he multiplied them by two different things. Okay? Okay, let's go to the last green, nope, 2 more green pages. I'm getting ahead of myself. So this is 184. And this is really for you to practice on your own. So I would very much like for you to try it and then go back and pause and then watch the video to see if you got them correct. Number 1, which model below shows a fraction equivalent to 2/6? So my suggestion is write down the fractions and butterfly them. So A is 1/2. We're going to butterfly that with 2/6. 2 times 2 is 4. 6 times 1 is 6. 6 and 4 do not match. So A is not equivalent. Let's try B. 1 out of 4. 2, 6. Butterfly. 4 times 2 is 8. Bottoms up butterfly. 6 times 1 is 6. 6 and 8 are not equivalent. So B is out. Let's try C. 1, 2, 3, 4, 5, 6, 7, 8. So 2 out of 8 and 2, 6. Bottoms up. 8 times 2 is 16. 6 times 2 is 12. 12 and 16 do not match. So C is out. Still looking for something to match. So we have 1, 2, 3, so 1/3 and 2, 6. Bottoms up. 3 times 2 equals 6. Bottoms up. 6 times 1 equals 6. They both equal 6. D is correct. They multiplied the top and the bottom by 2 to get that equivalent fraction. Number 2, which fraction would be equivalent to 3? So when we have a whole number, they are separated and we're not cutting them into parts, so we just simply put 3 over 1. So A shows a whole number. B is a fraction, not a whole number. C is a whole number, but it's the whole number 4. D is a whole number, but it's a whole number. Let's see what this one would be. 6 over 3. I need to change that to a 1 to figure out what they did. So that means I would need to divide by 3. Divide by 3. That would be the whole number 2. So we didn't want that whole number. We wanted the whole number 3. So A is the only one that has our 3 over the denominator of 1. Hope you remember to put your whole number over 1. All right, number 3. Look at point P on the number line. Does the point on the number line show a fraction equivalent to the fraction shown by point P? So let's figure out what our fractions are and butterfly them. So let's figure out P. 1, 2, 3, 4, 5, 6, 7, 8 is our denominator. And we're on 1, 2, 3, 2, 3, 4, 5, 6. We're on 6. So P is 6/8. Now I've got to find something equivalent. So let's check on A. A has 1, 2, 3, 4 parts. And they're on 1/4, 2/4, 3/4. So is 3/4 and 6/8 equivalent? Let's butterfly and see. Bottom up, 8 times 3 is 24. Bottom up, 4 times 6 is also 24. They both equal 24, so yes. That first one is equivalent. We can multiply the top and the bottom by 2 to turn 3/4 into 6/8. Or divide by 2 to make 6/8 into 3/4. All right, let's try B. So we're using 6/8 again because that was P, remember? So we have 1, 2, 3, so 1/3, 2/3. Let's see if we're equivalent to 2/3. Butterfly, bottom up, 8 times 2 is 16. Butterfly, bottom up, 3 times 6 is 18. 18 and 16 do not match, so this one is a no. You cannot change a 3 into an 8. That would be impossible to do. You could change it to a 6, but not an 8. All right, C. I'm going to come down here where I have more space. So remember, P was 6/8. We want to butterfly that with 1, 2, 3, 4, 5, 6. So 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. So 4, 6. Okay, let's go bottom up. 8 times 4 is 32. Bottom up, 6 times 6 is 36. 36 and 32 are not the same answer. You cannot turn an 8 into a 6, so this would be a no. So yes for the first one, no for the bottom 2. Your butterfly will let you know if they are equivalent or not. Make sure you're using that once you know what your fractions are. All right, page 185, number 4. Again, I hope you are working these on your own and then coming back and viewing it to see if you got them correct. Number 4, does the number line marked by the point on the number line represent one whole? Choose yes or no for each number line. All right. Is 1/1 the same as one whole? Yes. The numerator and the denominator have to match to be equal to a whole number 1. Okay. B has 4/1. Does that represent one whole? No. 4/1 would represent 4 whole. The numerator and the denominator do not match. Look at C. 1. Does 1 represent 1? Why, yes. 1 is 1. D, 4/4. My numerator and my denominator match, so it does equal 1 whole. Remember to equal 1, your numerator and your denominator must match. They have to match to equal 1. Now this represents 4, but not 1, and we wanted 1. All right, number 5, use the number line to find the fraction equivalent to 3. Okay, so we want to put a fraction under here. So let's count 0 to 1, 1, 2, 3. So they're each a third. So I'm just going to number them. 1 would be 3/3, 4/3, 5/3. 2 would be 6/3, 7/3, 8/3, and 9/3. So 3 would be equivalent to 9/3. Draw a model to find a fraction equivalent to 1/4. So let's do rectangle. 4 is my total, so I'm going to cut it into 4 pieces. I need to shade 1, and then to get an equivalent fraction, I'm going to cut this again. So we're going to turn our 4 into 8 by multiplying by 2. Whatever I do to the bottom, I have to do to the top. So how many pieces will I need to shade? 1, 2 to make it match. Now you could have done times 3, times 4, whatever you choose. I'm going to go with 2 because it's the easiest one for me to draw. So 2/8 and 1/4, we could easily butterfly those to prove they are equivalent. 4 times 2 is 8. 8 times 1 is 8. So I know they are definitely equivalent fractions. There's more than 2/8, but I'm going with 2/8 because it's just times 2. All right, and that's it on equivalent fractions. So your equivalent fraction slides with the dinosaur should be completely done and turned in for me to grade. You had a packet on equivalent fractions that should be completely finished and turned in for grade. And you've got your red pages from your iReady book that go along with our lesson on equivalent fractions. So next week we'll be working on comparing fractions using greater than, less than, or equal to. This past 2 weeks we've just worked on making them equal. But now we're going to start seeing how to compare them in our next 2 weeks. All right, have a great day.